I have a tech generalist background, right? I've done a lot of things around web development, cloud engineering, conversational AI, and digital marketing as well. But for long, what I've done most has been around cloud engineering, right? I volunteer as a dev advocate as well, and guest lecturer speaking on cloud computing at University of Oxford, Surrey, and recently at Sheffield Hallam University. And I spend most of my time with my wife, either watching K-drama or, or anime. Thanks for that. So in this talk, I'm not representing IBM, right? I'm representing myself, just putting that out as well. Right, so the goal of this session, right, the what really is to look at like overview of cloud native development and what are the architectures and technology that people use that they could say they are doing cloud native development, and why is really around what's the technical benefits and as well the business benefits of building apps that can take advantage of the cloud, and how would then goes into like the threat factor itself of how we can build cloud native app using the threat factor approach. So this is the persona for this talk, right? So Shuri is a junior full stack engineer, right? Right? Okay, sorry. But she doesn't have anybody under as junior, so I could assume she's junior as well. So our main point is that she doesn't know how to go about hosting her apps, right? She wants to embrace DevOps, microservice, and cloud native development, but not easy to use. But she doesn't like since find tools to use to do that, right? And she wants to embed AI into her application. So she's looking for API on the cloud and services she could leverage. And she thinks that productivity can be increased by leveraging serverless, startup packs, and DevOps, right? So Shuri is faced with several options. First option is like Ezra, the city of Paystack. She could decide to set up her own physical server in her house, right? That's if she has the money to buy like a server. Or she could use a local shared hosting service, like some popular ones. But she'll run into problems like she won't be able to scale her applications. And of course, she could join the cool guys and try cloud services like AWS, IBM, Google Cloud, whatever. So if you were Shuri, which of these options would you go for? Shuri the big boys. Okay, go. Cool. Well, yeah, of course. She wants to be like the big guys, so she goes for public cloud hosting. But really, why cloud? Yeah, I think around cloud, there are three major reasons why you want to use cloud as opposed to any other option to host your application. The first is really speed and agility, right? If I'm on a cloud, I could create a server within like a minute. I have a server to host my application. That's speed, right? And there's agility. I could go from maybe using a platform as a service, something like Heroku or AWS, Lightsail or EBS, sorry, to using a container as a service, like AWS container service, ECS, yeah, or Google Kubernetes service. So there's option. You can really just move from one kind of hosting flavor to another, right? There's speed, there's agility. And it's cost saving, right? As opposed to someone like Ezra. Ezra is very rich. He's always buying like physical servers, like in his house, right? For you to set up a server, you need to pay for the server first before you can host your application, right? But on the cloud, you don't pay first. You use, then you pay, right? So that's the option. And scalability, right? The fact that it's easy to scale your application, right? Within few minutes, if you think that, oh, I need more instances of my application, right? You could go to the cloud and spin more instances for your server, or more instances of your node if you're using like a Kubernetes or a container. And there's just different hosting service in the cloud, different options. You can choose to do platform as a service, like I mentioned earlier. You can do container as a service. You can even choose to do serverless, depending on your choice, right? Fine. Now, Shuri has hosted in the cloud. She has decided to go with setting up maybe a virtual server, and she has hosted the application in the cloud. But like, there's more to hosting your app in the cloud. That's what she realized in her journey as a junior full stack engineer. Now she's getting to the point of becoming a senior engineer. Then she finds out that there's limited scalability with the way that she's currently writing her application. She's not taking, like, we've seen that the advantage of cloud really is around speed and scalability. But it's possible for you to build application that won't be able to take advantage of that, right? And that's really the point of this talk. Like, it's not just about building your application. Are you taking advantage of the cloud? Or can your application take advantage of the cloud if there is need for it, right? So there's limited scalability. She's doing manual deployment, right? Which is very slow. And our deployment is not repeatable, is not predictable. And our code is tangled with dependencies and config. If you want to create like new instances, because there's like tangled dependencies and config in our code, it's really hard for her to take that same code, put it to another instance and things like that. And she sees that she needs to rewrite her application, right? Now, because maybe there's a better way to write our app to take advantage of the cloud. And this leads us to cloud native development, really. And cloud native development is really about how do you build applications, right, faster, that can take full advantage of cloud. And taking advantage of cloud is that you can take advantage of scaling, resiliency, and agility. That means you are building an app that can scale, an app that is resilient, and an agile app, right? And the elements of cloud native is really, like I said, is a way to build an app. It's not really about where your app is hosted. People get it wrong. Cloud native development is not where you are hosting your app. You could be doing cloud native development and actually host on a physical server. If you set up like Kubernetes on your physical server and you do cloud native, you could host on like your own private server, right? It's really about how you are building your app, not where you are hosting your app. And usually, the major technologies are containers, like using things like Docker and microservices, or you could also be doing serverless, right? And the practices around that are really doing things like CI, continuous integration and deployment, right, to automate the deployment of the application. And now, Shuri knows about cloud native development, just like maybe some people are just knowing about cloud native development now, right? So the next question is, where and how can I start, right? So that's a very important question. And where you can start is the 12-factor approach and containerizing your application. So if today you want to start doing cloud native development, the best way to start is all the codes I already have, go and add Docker files to them. Make sure that they can run within a Docker container, right? Make sure that you can build them as a Docker container and you can run it in a Docker environment. What that means is that same application, you can host it on any cloud platform that supports containerization, any platform that supports Kubernetes, you can host it anywhere. That's what it means. So that's like one of the best ways to start. So even if you have like a React application, you can go now, maybe after this talk, to see how can I containerize my React application? How can I add a Docker file to my source code and help me to be able to containerize this application so that it's easy for me to host. And what that means, by the time you containerize the application, it's easy to scale the application because as a container, what just means that on any cloud platform, they could just create new instance of that Docker container, right, on whatever technology that they are using. So let's quickly look at the 12-factor approach. the 12-factor approach is really around 12 important characteristics of cloud native app. It was introduced by early Heroku team, right? Because Heroku were the first set of guys that really did like platform as a service. And based on their experience working with a lot of clients, a lot of developers, they discovered that there are 12 major things that people were doing wrong and that they could do right in building the application, right? So we just look at those 12 basic things, right? And yeah, we can take questions. So the first thing is around the code base. And what the factor around code base is that for every application that you have, you must have a repository for it, right? At least, and that's like the first step to even doing CI/CD. If there's no repository, you can't really do CI/CD, right? Yeah, so for every application you have, it should be on a GitHub. It shouldn't be deployed directly from your system, right? There should be a GitHub somewhere where you are putting your code base. And the next factor is dependencies. So on dependencies, what Heroku team discovered was that a lot of people were not separating like dependencies from the code itself, right? And this is something that Node.js has really like perfected with things like NPM. With NPM, you can define your dependencies and it's separated from your code. And most time you git ignore your node modules, right? Because you now put it up, so it's not up to the platform where you are deploying your application to determine how it's going to install those dependencies. But what you need to do is to make sure that you are not bundling the dependencies into the source code yourself, but you define them. So there's a difference between defining and bundling dependencies. So you define them using tools like package manager, like in Node.js, it's NPM. In Java, sometimes people use Gradle or Maven. Ruby has its own as well, and a whole lot of other programming languages. All right. So ensure that you are separating your dependencies. You are not putting your dependencies into your source code, but you have a file that defines it. And for config, the interesting thing about config is that there's sometimes we are using databases in our application. So we are connecting that database to your application. So are you separating your config from your code, right? Do you like push your config into your source code? It's a bad practice, not just because of security, because your API keys, your connection keys can be exposed. It will also stop you from being able to scale your application in the sense that means every time that there's a change in your database, you need to go and rewrite the application and redeploy it. What Heroku has suggested is that instead of having it in your code, you can keep them as environment variable. So it's up to the environment where you are deploying your code to get those variables from, like your database credentials, your API keys. It's up to the environment where you are deploying the code to get those information from. And then backend service. Backend service talks about around how we should treat attached resources as backend service. And what does this mean? For example, we are using like an email service within your application, right? Maybe you are using SendGrid, and tomorrow you want to use MailChimp. How easy will it be for you to make those changes without having to rewrite your application? For example, there's a very good example. There was sometime last year when something happened with the Monify Providence Bank connection, right? For their Reserve account API. And they had to, so within like some hours, and this impacted like Piggyverse and a whole lot of other apps that were using that API. And within like some hours, Piggyverse was able to make changes, redeploy like the reserved account API, and everybody had access to that reserved account API. So they made, I think they changed from, they changed to Wema Bank or, I can't remember. So it was easy to do that because that part of the application is treated as backend service. So it means that, okay, you're writing your application in such a way that any external API that you are using, you can easily replace them without having to rewrite like the entire code, right? So maybe it's just up to just changing like some API credentials, and everything is still fine. Maybe you can just change from SendGrid to MailChimp, everything is still fine, you can still send email, you don't have to redeploy the entire code. Then point 5, build, release, and run. It's the point that talks around CI/CD, making use of CI/CD to do automated deployment in your application. And what that means is that by doing this, your application is predictable and is repeatable. You can repeat your deployment on several platforms by doing CI/CD. And on processes, right? Processes is around making use of like stateless process. Try as much as possible to make sure that your app are stateless. And what stateless means that, for example, does the application rely on like a file to work? Maybe you have to open something from a file, like a status from a file. That application already has states. Or are you relying on like sessions and things like that for your application to work? If you are thinking around scaling, right, then you need to try as much as possible to make sure that your application is stateless. And port binding, these are like somewhat advanced, right? But it's just something around how you should bind your service. This really very applicable to when you are doing microservices to a certain port in the environment, so that it's easy to communicate from one microservice to the other. And concurrency. This concurrency is the very interesting part. This is the part that talks about scaling, right? Concurrency is that, are you building your app in such a way that you can scale horizontally? And what that means is that if you have multiple instances of that application, right, you'll be able to attend to more requests, right? And for example, if you are attending to 10,000 requests before, if you have like another instance, would you be able to attend to 20,000 requests? Are you building your application in such a way that you can leverage concurrency in your application? And disposability, also around, by the time you are spinning up several instances, maybe there are times that your request now goes down, there's a spike. You should also be able to dispose certain instances that are not needed at that point. So you should write the application in such a way that it's easy to dispose. You can gracefully shut down. Admin processes are things like maybe database seeding or database migration in your application. So the approach here is that make sure that you don't have to go and write like an entirely new source code for the admin process within your app. Everything is within the same source code, even though it's running as a different process. But the entire thing in your application, the admin process, and the app itself is within the same source code. That's like what the Heroku guys termed as threat factor. And I think that if you follow these, you'll be able to build apps that can scale and that are resilient, right? Thank you very much for your time.